No.
Right, let's go.
So
Q&A.
yeah, questions from the floor. Yes, sir.
So I got a couple of questions. So, my main question is like, what's the main challenges that you guys face during this project in terms of fabrication and also in terms of measurements?
You want to take that measurement application? To start.
Okay. So our main challenges in terms of fabrication and
Measurements.
measurements. For fabrication, actually we don't really have much challenges in fabrication. Our main challenges would be when we actually designing our whole setup, mainly because of our space constraint, and then actually our space is really small, and then we only have a leeway of so OHS requires we have 80 centimeter of walkway, but what we had in the lab currently is 90 centimeter something. So we only have 10 centimeter leeway, of which we can use when we're designing our facility.
And what Fatih is talking about is the space between the
table
and the end of the facility. So it's actually an enclosed area. So between that and that is only 90 centimeters, of which, so we can't really pull or push too much of the facility. We need to take care of the space.
And in addition to fabrication, because most of the things that we do requires external help, and especially so sometimes getting the right time and right materials on time is the difficult part of the project. So essentially, because of these problems, so there are delays in actually doing the fabrication.
I think the main challenge comes when we try to put the parts together, which we are trying to do it now. What we have right now is, so what the pipe needs to be is pretty much essentially straight. Our tolerances is actually 10 micrometers. So if there's more than 10 micrometers, what we'll see in our turbulence reading is that it's distorted. So we need further cleaning on our data. So what this requires is that when we join the pipes, as you can see, the pipes has to be squared, and pretty much when the two pipes meet, you cannot have any bumps or anything, or any significant bumps. So that's a key challenge when you don't have the advanced machine toolings available.
In simpler words, is when you guys are driving on the road, and there will be some, especially for a bridge. So in construction, they will actually construct different components of bridge at their factory, and then they will transport it to the site, and then they will actually combine two sections of bridge together. So what we're trying to do is actually attaching those two bridges, so that when you're driving, or actually when you're walking on the bridge, you can't actually feel that there's that there are two different sections, but rather it's actually from one. So the connection has to be really perfect if we want to get a laminar flow at higher in a number. So yeah.
Any other questions from the floor?
So, in this design, where is the measurement system again?
Oh, okay. So the measurement system is gonna be.
Is
there a mouse on there? There's no mouse. Yeah, it's gonna be at the end,
Okay.
but we're gonna have pressure taps along all of the pipes. So basically we're gonna measure pressure
This one.
at. Okay.
Okay.
Yeah. So we're gonna measure pressure at every 1 meter. So we're gonna have one pressure tap here, and every 1 meter. And then because we're using differential pressure sensor, so we're gonna fix one pressure tap to one end of a pressure sensor, and then those 9 other taps, which are 1 meter apart from each other, is going to be connected to the other end of a differential pressure sensor. So what that differential pressure sensor does is that it calculates the difference in pressure at the first pressure tap and at the second pressure tap. So that's gonna be the pressure measurement system. And yeah, so we're using just one differential pressure sensor, and then we have to design on a way on how we can use that one pressure sensor to actually measure the pressure difference in 10 different pressure types. So that will be our next design objective for pressure measurement system. Okay, hope that answers.
Any other questions from the floor?
I have several questions though.
Oh, several. Thank you.
Yeah.
Sounds good.
Alright. Can you clarify on how do you actually planning to straighten the flows through the device?
Yeah, I think Dani will be the one.
Yeah, we'll show the slides. Yeah,
Better
Dani
to
will
explain
explain it.
ADs, how we destroy small
This is
ADs.
PDAD.
Yep. So basically, as mentioned before, that we want to minimize the AD currents around the flow, right? So that's why you can see this is the honeycomb mesh. So basically, as the flow goes to the flow device, it will, there's lots of wave, what do you call it? Like eddies, right? And then when it hits the first honeycomb, it will squeeze the flow, so it will run,
It's like squeeze the eddies.
yes, because eddies and this will go smoothly through the honeycomb, and then we use 2 honeycombs to make sure that it goes very straight. And then later on, we use a metal mesh that has a smaller diameter than the honeycomb, so it will be squeezed again. So hopefully, by using this 3 sections of 2 honeycombs and 1 mesh, it will then be reduced until it,
So basically, after the mesh itself, any existing eddies will be compressed because of the contraction. Because the contraction itself accelerates the flow, and when it accelerates the flow, it pretty much kills off any turbulence that is smaller than 0.1 millimeters, which is the size of the mesh.
Next question will be, what is the flow rate that you guys will be expecting?
Okay.
Tapi,
So yeah, when we design our MATLAB, or actually when we code our MATLAB, so here it is. When we design our MATLAB, we wanted to know the exit velocity, and from exit velocity, using continuity, as I've mentioned before, we can find the flow rate. So when using the current setups that Adin has proposed for the main tank and auxiliary tank, we're gonna have at most 3 meter per second velocity or 18 liter per second flow rate. So from there,
50.
At most 18, but 15 is the one that we're gonna set using our control bar, because and then that will be compensated by the flow back pump after the collection time.
Thank you.
Is that all, sir?
Nah, that's all from me.
I have some questions as well. So how do you measure the energy losses through the flow straightener device?
Okay, so
Complicated question.
right, yeah, that's I think among all that will be the most complicated question. So I believe this is a very bright engineering student here we have. So okay, so after let me return back to the theoretical concept that we use. So here, what we have here is head loss equation. So head loss also means energy losses along a pipe, but this is along a straight pipe that has no honeycombs or meshes or
Single
any
parallel pipe.
single parallel pipe. Yeah, that's a good way to summarize everything. So after consulting with our supervisor and our senior from William, a PhD student, and Kevin, a postdoc student, we believe that it is really hard to measure energy losses throughout the flow straightening device, mainly because there are different sections that we can't actually get precise measurement of honeycombs diameter, each of them, and then so because of that, we just settled to sort of estimate the percentage of losses that we're gonna get when the flow ran through device by 70%. Or sorry, 50%.
So to compensate this uncertainty, that's the reason why we have a control valve, and also what we did was we increased our head a bit more so we have a higher velocity, just in case if the flow straightening device
Yes.
is much more than a 70% estimate as ours. There's no research papers that provides any
Way to
calculate flow straightening device.
Yes.
So what we tried to do is we tried to control the flow instead
Yes.
to
So that's
to mitigate the issue.
yes, to mitigate. Alright.
You have a question?
Any
So
more
one
question from
last
the friends?
question. So how are you going to plan to make the perfect connections between the pipes?
Oh, I think that's a question that I didn't I'm gonna answer.
I have a slide outside of this to show you. There. So, the biggest concern is that the two ends needs to be matched perfectly. So our pipes are actually not that bad, even though it's designed for sewages and stuff. So normally they're only out. The pipes itself, they are only bent of a maximum of 100 micrometers, which is not too bad. It's good actually. So what we did was we tried to square the edges of the pipe ourselves. We did it with the CNC miller. So we milled the end square, so the edges of the pipe can connect to another edge of the pipe pretty much 90 degrees to itself. The key thing is trying to keep that in place. So what we did was we tried to design a mold or a clamp to join these two pipes together. And what we had was the clamp is also made out of PVC pipe, so that the two pipes and the clamp can be glued together and be bonded permanently together to ensure that the pipes are straight and also that they are leak-proof. Does that answer your questions? Alright, thank you very much. Is there any other questions left to go? Man, you?
So is there another questions about the cost? Because just now you mentioned about the cost.
Yes.
So,
What about the cost? Keep going, sir.
so do you have any target cost that you
So that's thank you. Yeah, so it's a tricky question because there's a funds allocated for this project. When we first met our supervisor, the first thing he said was that try to think of the design without constraining yourself with the cost. But obviously, any good design needs to be effectively costed. If not, you can just buy anything, and if you misjudge something, buy another one. So there's no restriction of the cost, but a facility like this overseas or something that other universities have done, you're looking at one section. So remember the section that I was saying with the pipes joining and stuff. That pipe joining section itself will cost around about $5,000. But our facility, as you can see from the bottom, we've managed to try to compress everything below $10,000. So to answer your question, a reasonable estimate is somewhere between $10,000 to $30,000. It's a large gap, but that's something that we could foresee accumulating for our cost. But yes. Any other questions?
That's all from our bright student. I think
Right. So I guess.
Yeah.
So. You want to sum up? So I guess I'll thank the panel, and we'll end our initial presentation for this show. So thank you for listening, and hope to get good feedback from you. Thanks. So honest feedback, put up like.